So in the first case, both the forces are acting in the same direction, while in the second case, these forces are acting in the opposite direction, right?
Opposite direction.
Yes.
Yes.
We have to find the resulting force and the direction in which the box will move. So when F1 and F2 both are acting in the same direction, then
The box will move to right direction.
box will move to the right direction. And when F1 and F2 both are acting in the opposite direction, then it depends upon the direction of greater force, right?
Okay.
So first,
Yes.
let's take the first case when both the forces are acting in the same direction. So when both the forces are acting in the same direction, then we find net force by adding these two. And net force is 450 Newton. We are getting here.
Okay.
And if both the forces are acting in the opposite direction,
On in opposite direction,
then one force is exerting from this side, other force is exerting from the opposite side. Then what we do? What do we do then? We find the net force by
uh,
subtracting the forces. So when they are acting in the same direction, then we add them. But when they're acting in the opposite direction, then we subtract them.
okay.
So if F1 and F2 are acting in the opposite direction, then we simply subtract them and we'll get the net force like this. And what is the direction of net force here?
Where?
Second case, when the forces are acting in the opposite direction. So what is the direction of net force?
Direction of net force. Right?
It is the direction of greater force, no?
Yes.
Yes. Direction in which the larger force, 275 Newton, acts is the direction of the resultant force. So if the 275 Newton is acting from this direction, then it is towards right. And if 275 Newton is acting from this direction, then it is towards left. That depends. Okay? Easy?
Let's do another.
Its direction can change, its speed can change, it can come to rest. And if it is already at rest, it can start moving. The shape of the object can be changed on the application of force. So we may make an object move from rest. We may change the speed of the object if it is moving. We may change the direction of motion of the object, and we may bring about a change in the shape of the object, right? And may cause some or all of these effects. So whether it is possible that we observe just one effect or we can observe number of effects together. Okay. So none of the above effects can take place without the application of force. If we do not apply force on an object, then we do not observe these effects. We observe these effects when we apply force on any object. Now you have to identify the agent exerting the force, agent which is responsible for exerting the force, object on which the force acts, and the effect of force. So let's take the first situation. Here we are squeezing a piece of lemon to extract the lemon juice. So what is, name the agent exerting the force?
Agent exerting a force. Yeah.
The thing which is
Like
exerting the force on the lemon for squeezing it.
hands.
Okay, person holding the lemon, yes. And the object on which the force acts?
What?
The object on which the force acts. On which object we are exerting the force?
On which force acts? Object on lemon.
Yes, it is lemon. And what is the effect of force? So
So
when
that the lemon juice can come and he can easily collect it, or
there is a change in shape also, no? Of lemon, you can
yes.
the change in the shape of the lemon, right? Next topic, taking out paste from a toothpaste tube. Name the agent exerting the force.
He is pushing out the toothpaste with his hands.
Yes, person holding the tube is the agent exerting the force. And the object on which the force acts is
On the
the,
tube.
yes.
Tooth.
And the effect of force,
That effect of force is that it can change its shape, like when it will come, then there is a change in shape.
there is a change in shape. A load suspended from a spring while its other end is on a hook fixed to a wall. See, weight is acting in downward direction. No?
Hmm.
Weight, the weight, it is connected with the spring. So one end is connected with the weight and other end is connected with the wall. So agent exerting the force is weight of the load.
Hmm.
Because weight of the load will act in downward direction. Right?
Yes.
And what is the object? Name the object on which the force acts.
Object spring.
Yes, it is spring. And what is the effect of force?
That it changed shape. Before the spring was um, in
Spring,
the
there will be extension in the spring. Spring
yes.
will stretch. When we connect
Yes.
both to the spring, it will stretch in downward direction. Its length will increase, right? So there is change in shape. Next,
Yes.
an athlete making a high jump to clear the bar at a certain height.
An athlete making a high jump to clear the bar at a certain height. Okay. Uh, Making a high jump to clear a bar.
So what is the agent? Name the agent exerting the force.
Athlete.
The object on which the force acts.
Object on which force acts. Bar.
Is the ground. And the effect of force.
Um
Effect of force is
Effect of.
the change in state.
Okay.
Yes?
Like the athlete was before there and
After jump
after.
and before jump. There is a change in state of motion, right?
Yes.
So what is state of motion? See, both the rest and the motion, they are regarded as state of motion. State of motion does not mean that the object is moving. It tells us about the state of the object, whether it is moving or at rest.
Okay.
Okay. And if the object is at rest, we say that the state of motion is rest. While if the object is moving, then we say that the state of motion is motion. It is moving, yeah? Right?
Hmm.
So rest and motion, both are the state of motion. It is described by speed and direction of an object. Okay? We can describe state of motion by the speed of the object or the direction in which it is moving. The state of rest is considered to be the state of zero speed. If the object is at rest, it is not moving at all. Then the speed is zero.
Yes.
Then the speed is zero. So state of rest is the state of zero speed. State of rest is the state of zero speed. So will the application of force always result in the change in state of motion?
Will the application of force always result in change? Uh,
If you apply
yes.
force on an object, then its state of motion will change.
Change.
Is it applicable
Yes.
everywhere in all cases?
What?
See,
Uh,
consider a situation. You are on a hill,
Hmm.
okay, and you find a rock, a big rock. It is moving down towards you, and you are
Okay.
applying force on it, force on the rock to stop it. So can you stop the big rock?
No.
But you are applying force on the rock now, so it will stop. It should stop now, but it will not
Yes.
stop. Though
Because it's heavy and
because
it's
it's
big.
very heavy and you cannot stop it.
The mountain is slow like this, so
Incline.
the rock will change its speed and like high.
Okay. Okay, let's consider another situation. If we have in place of rock, we have a pebble, small
Hmm.
pebble. So can you stop the pebble which is moving
Yes.
towards you? You can stop the pebble, though it is rock is again. See, hill is the same, na? It is inclined and the pebble is moving in the downward direction. But you can stop the pebble, but you cannot stop
Yes.
the rock. But because for pebble you need small amount of force, right? A very small force is sufficient to stop the pebble. But for rock,
For rock, we can't stop it,
because it is
and
huge.
we need we need more force to stop it.
Yes, you require more force to stop it. So you can't stop the rock. So application
Yes.
of force doesn't always result in the change in state of motion, right? Force is if the force is sufficient to change the state of motion, only then its state will change. Otherwise, we cannot change the state of motion, right?
Hmm. Yes.
Change in the state of motion occurs only when the applied force is sufficient enough to change the state of motion. So if the applied force is insufficient to change the state, then there will be no change. Or we can change the speed or direction, but we cannot stop the object if it is heavy or huge, right? And we are applying insufficient force, right?
Yes.
Next question. So next we
Factors
have
on.
factors on which the effect produced by the force on an object depends. So on what factors does the force on an object depends? So force on an object depends upon the magnitude of force. Magnitude means the strength of force,
Hmm.
how stronger the force is or how weaker it is. Okay?
Yes.
Magnitude means its strength and direction of applied force. In which direction you are applying force on an object,
Okay.
right? And the third one is point of application of force. So these are the three factors on which the effect produced by the force on an object depends. When we apply force on an object, it depends upon three factors. It depends upon the strength of force, it depends upon the direction in which we are applying the force, and it also depends upon the point of application of force. Okay?
Okay. Yes.
So next we have types of forces. So there are different types of forces, and we categorize all these forces into contact forces and non-contact forces. So what do you think? These contact forces, what should be the definition of contact forces?
Contact force is like moving a table.
Okay, so how do you say that it is a contact force? How can you say this? Is there anything in contact with each other? Is there anything which is touching or physical contact? You see,
No.
there is no physical contact.
Uh, like
When you move the table, the legs of the table and the floor, they are in physical contact, right?
yes.
So it is a contact force. Frictional forces. These are frictional forces. When you apply force on the object, then frictional force comes into play, and frictional force is the contact force, right?
Yes.
Okay. And suppose I have a marker in my hand and I just release this marker. What will happen? It will go towards the
Down.
floor. right? Why? Is there any force acting on the marker? When I release it, it goes down. Is there any force acting on it? Hmm?
Due to gravity.
Due to gravity means gravity exert a kind of force, right?
Yes.
That force is called gravitational force.
Hmm.
And so, do you see any physical contact, any touch between the marker and the earth or the floor? There is no physical contact, right?
Yes.
This kind of force is called
Non-contact forces.
non-contact. So contact forces are those that can be applied on the body if one body is in contact with the other. So when two objects are in physical contact with each other, then we say that the contact forces are acting. And when there is no physical contact, then we say that they are non-contact forces. Okay.
Hmm.
Now let's start from contact forces. So we have two types of contact forces. The first one is muscular force and the second is frictional force. So muscular force is the force exerted due to the action of muscles. Due to the action of muscles, the force that acts is called muscular force. For example, force used to lift a school bag, force used by animals to pull a load. Muscular force enables us to perform activities like movement or bending of a body. Lungs expand and contract during breathing. Food gets pushed through the alimentary canal. So these are all examples of muscular forces. Okay. And second category is frictional force. And frictional force arises due to the irregularities between the surfaces in contact. It always acts in the direction opposite to motion. So if we are moving a table in a specific direction, then frictional force acts in the opposite direction to stop it. Okay.
Yes.
Why does it occur? It occurs because of the roughness and it occurs because of the irregularities between the surfaces. When we move the table, then the legs of the table, right, and the floor, they are not perfectly smooth, na?
Yes.
They look smooth, but they are not perfectly smooth. In
Hmm.
microscope view, we can see the irregularities between the two surfaces, and these irregularities get interlocked. Suppose these are the irregularities of the floor and these are the irregularities of the table. Then when we move the table on the floor, then they get interlocked like this. Okay, and we need to move this interlocking. We need to move the table against the interlocking. So, right?
Hmm. Yes.
We have to move the table, and for this we need to remove this interlocking. So we need to apply sufficient force to break the interlocking.
Okay.
Okay. So this force is frictional force. For example, rolling ball stops after some time. It stops because of
Yes.
the irregularities. And a car or a scooter comes to rest when the engine switches off due to friction between the tires and the road. So these are the examples of frictional force. Okay.
Yes.
Any doubt?
No.
Next, we have non-contact forces. So non-contact forces are of three types: electrostatic, magnetic, and gravitational forces. The word electro means charge and static means rest. So these are the forces which exist between the charges. Okay, the force exerted by charged object on another charged object or uncharged object is called electrostatic force, because as we know that like charges repel each other, unlike charges attract each other, right? For example, a straw rubbed with paper attracts another straw. Two straws rubbed with the paper repel each other. So these are the examples of electrostatic force. Next, we have magnetic force. In magnetic force, we know that magnets attract or repel, right? When we put two like
Yes.
poles together, then they repel. And when we put two unlike poles together, then they attract. North-north, in north-north, we have repulsion. In north-south, we have
Yes.
attraction, right?
Attraction. Yes.
Yes. And gravitational force, we all know that every object in the universe attracts every other object with a force known as gravitational force. A coin or a pen falls on the ground when it slips off your hand. Leaves and fruits fall to the ground when they get detached from the tree. So these are the examples of gravitational force.
Hmm.
Easy?
Yes.
Now you have to identify the force which brings the ball down when thrown upward. Name the force.
Which brings the ball down, then thrown upward. A gravitational force.
Very nice. Next, due to which magnet attracts the iron?
A magnetic force.
Good. Foam rubbed with hair attracts pieces of paper.
Yes, and it's electro electro.
Electrostatic force. Next,
Hmm.
food gets pushed through the alimentary canal.
That's
There are muscles in a body, na? Which helps in
yes.
pushing the food downward direction, in downward direction. This is muscular force. We will be studying about this muscular force in higher classes when we'll study the digestion. Rolling
Okay.
ball stops after some time.
That's moving wall stops after some time. Oof.
It stops because of the irregularities between the ball and the floor.
Yes.
And
I
these
forgot the names of.
irregularities interlocked, right? And we need to break the irregularities.
Hmm.
Then we can move it, right? That force is frictional force.
Yes, I forgot the names of that.
Lungs expand and contract during breathing.
That's muscular force.
Very nice. Two balloons rub together, repel each other.
Magnetic force.
We are rubbing two balloons against each other. There is no magnet.
Electrostatic force.
Yes, it's electrostatic force. Apple falls on the ground when it get detached from a tree.
Gravitational force.
Now we have electrostatic force. I think we should start this electrostatic force in the next class. I'll take your 1.5 hour class on some other day because you have joined late today. So I have to end the class here only. Okay.
Okay. Hmm.
And